My name is Jonathan Tickner. I'm the Chief Data Scientist for Intelligence Solutions at L3 Data Tactics, and I'm here to talk with you about Big Data Ecosystem's new network defense application. CyberDetective is a behavioral analytics tool for anomaly and outlier detection in cyber networks. So what I mean by cyber networks is firewall traffic, netflow traffic, so any network traffic that's coming across the wire. So what you're seeing here is the live streaming view of a test network we have in McLean. This network is using firewall traffic, and we are plotting both the source IP address and the destination port of the traffic crossing that firewall. So the blue nodes here are external IP addresses, green nodes are internal IP addresses, and then the gray are the ports. We're using this IP to port connection to show the behavioral component of the users. So if I fire off one of these scenarios we have from a previous customer, you'll be able to see a larger pool of data into the network. So now as that network traffic comes in, we begin to see the nodes added, and again, once that node has been added, if the traffic occurs again, we see red blinking. So it becomes very apparent that we have large number of IP addresses that have been added to the network, as well as a large number of ports that appear to be getting scanned by some of these external IP addresses. So for instance, if we look at this IP address here, we notice that the color is blue, so it's external, and we see significant number of ports that are being accessed by that individual IP address. So if this person were to do this at a slower rate, our volume-based detection methods might not be able to discover that this person is actually in reconnaissance mode, but the visualization, because we hold a larger pool of data, will be able to see that information live. If we go to the heat map view, we can begin to see where this network traffic is coming from. So just very apparent off of this this network scan that we see that the traffic is coming from the eastern coast of the United States. So with the power of BDE, we can leverage all of that external information, we can plot that on the map, and we can begin to see where this traffic is actually coming from. Also in this live streaming view, we have an outlier detection window that's using our 4 algorithms that we use for detecting anomalies and outliers, but it's running this algorithm as a sort of sliding window, if you would like. So this algorithm, every 5 minutes, we are calculating over the last hour's worth of data, and with that hour's worth of data, we run each of the algorithms, and then we provide a score for each of them. So for instance, if we go through, we're not seeing anything that's highlighted in red. If we go all the way down to the unique community outliers, we can see that this particular community, community 1, is highlighted in red. That means it is a significant outlier. So if we click on that community, it brings up that user's traffic. We can quickly see that's external IP address, the port that it's using, and the weight. So again, it allows us to not only calculate these most meaningful outliers, but provide a quick visualization of what's happening. Now let's say that we're interested in looking at a larger pool of data, not just what's happening on the network right now, but we might want to see a larger swath, and we might want to analyze a larger pool. So what we can do is we can go to the historical view, and it allows us to select dates and times. So for instance, we can select all of today's network traffic. And what that will allow us to do is it will go and fetch the data that we have collected on our network over that time period. It's going to run all of the algorithms against that entire pool of data, not just 1 hour increments, and then it's also going to pull that data, build a graphical form, and do that layout. So you're going to be provided with both a visualization as well as outlier detection approaches. So you're going to be able to look at these things in the context of a larger pool of data. So what this helps us with is some of our advanced persistent threats, which might not appear over a smaller window, but as we look at larger and larger pools of data, we begin to see that those individuals will start to show themselves. So as that traffic comes in, what you can see now is a larger pool of that data. So we can begin to see all of the network activity here in the center. This gives us an idea of the typical behavior, and we begin to see also some of these large scans. So in the live stream view, we saw the scan. We can now see that these 2 IP addresses are scanning. And we see some activity out here on this particular port. If we zoom in, this is Telnet. So this, again, provides us that quick view of what's happening in the network. What BDE provides us on top of CyberDetective, the idea is to leverage the power of BDE with the large data pool that we have. So for instance, we can go in here, we can analyze traffic both from a network IP perspective, a port perspective, and a country perspective. And so that allows us to filter all of these nodes down. So we can see, for instance, that 800,000 plus packets have come through the United States. So for instance, if we want to analyze, say, 3389, this is our terminal server. This is someone who might be interested in a remote shell. This could be both normal and nefarious. We can click on that. It filters it down. We can begin to see that there are a number of IP addresses, all of them external to our network. Where it really gets interesting is we can go to our heat map view and we can begin to see where that traffic is coming from. So we immediately see we have China, Russia, and Europe. We see these large pools of dense traffic coming from 3389. So that's something that's very interesting to us. Also worth highlighting that on the bottom we can see the traffic as a function of volume. So we notice really quickly that there are two really large bars here of traffic that seem to be swamping the rest of the time period. So if we click on one of those, we can then see the traffic over that small period of time, which gives us a better view of not necessarily what happened over the entire duration, but what happened during that period. So immediately we can see that the individual that we saw earlier with the large port scans happened during that time period. We go to the outlier detection view, and so what that's going to do is going to provide an analysis of the entire pool of data. And so just to give you a sense of what these algorithms are, the first two, the port allocation and the port ratio, what we're looking at are both the number of connections and the weight of the connections for the individuals in the network. So port allocation is going to find users who spread that activity out over multiple ports. This could be things like pulling data from multiple servers, large port scans on the network, compromised credentials that are spreading out across multiple servers. Port ratio, this is going to be things like brute force attacks, password cracking attacks, data exfiltration to a staging server, or command and control communications. The dense community outliers, what that's doing is it's looking for coordinated behaviors both internal and external to the network. So for instance, if we click on that community, we can begin to see the traffic is on large ephemeral ports and it's coming from an external space. So by looking at that dense community, we can find coordinated behaviors both internal and external to the network. The final is our unique community outlier. That is finding activity that is different than the rest of the network. So for instance, if we click on the top score here, the person's accessing port 13,019. It's something very unique to this network. We might be interested in figuring out what that is. So we have a second scenario from another customer where we noticed our community detection outlier algorithm detected a coordinated attack that appeared to be coming from external IP addresses to the network using a remote shell. So if we click on this scenario, what we will see again is additional traffic being added, so we can see some of the new nodes popping in. So nodes that are accessing the typical web traffic that we saw before. But if we do a sort of refresh of the layout, we begin to notice very quickly that there is a group that starts to pop out over here at the top. We can see these IP addresses are very close together, so using these gravity-based algorithms, nodes that are closer together have more similar behavior. So we can begin to see that not only do they separate from the rest of the network, but they tend to coordinate very well with one another. Another thing to note is how dense the lines are here between the users. It appears that each of those ports is being accessed by each of the IP addresses. So this is what we would expect from a highly coordinated activity. So again, we can refresh the view and we see this group is being pushed even further away from the internal network space. So this is something, again, that just using the visualization power of BDE, we can see the activity of those users is anomalous compared to the rest of the network.